Hey, welcome to 6502 Emulator in Python Part 6 with Tokyo EdTech. That is me. In today's installment, we got a lot of stuff going on here. We're going to implement a compare method, so a compare command, so we can compare two values in the memory. And then the way this works is the comparison affects the flags. Then based on the flags, we can branch. We can go to a different part of the code. So in the previous video, we did jump. So, we used the jump command, but it always jumped because, there's no testing. So finally, we're going to be able to test. But to do this, we got to add another mode called relative mode, and I'll talk about that when we get to it. And yeah, just as a reminder, I haven't worked this out ahead of time. I have some ideas, and we're going to go ahead and you're going to see it live. I'm going to make mistakes. Some things will work, some things won't. Mistakes will get through. It's part of the journey. All right, let's go, cowboys and cowgirls. So last time, as I mentioned, we implemented the jump command. So this allowed us to create a loop. So I'm just going to go ahead and copy this over to my scratch pad because I'm not going to need that for now. Let me go ahead and this was test jump. All right, so I'm going to save that for later if I want to come back to it. And as I mentioned, we're going to be implementing, let's go take a look over here. And I did look up a few things here. We're going to be implementing first the CMP command, which I like to think of as chocolate, marshmallow, and peanut butter, my favorite ice cream as a child. But we're going to be doing compare. So you can see what it does here is it compares a value, and that value can come from, it can be immediate, it can be a value right in the next memory spot. It can be a value in the zero page X, absolute. I think we've already, I think we've implemented most of these, but we're just going to go ahead and work with immediate today. Because once that works, then the others are very easy to add. Now the trick here is that it compares the value. Then what does it do? You can see here it says affects flags N, Z, and C, or Z, of course, for our British, Australian, and Kiwi friends. So compare sets flags as if a subtraction had been carried out. If the value in the accumulator is equal or greater than the compared value, the carry will be set. Okay, so greater than or equal, we set carry. The equal and negative flags will be set, or the equal and negative flags will be set based on equality or lack thereof and the sign of the accumulator. Okay, so this is a little tricky, a little bit of tricky stuff here. So let's just go ahead and implement it, and we'll have to come back to this because again, I don't have this memorized. So the hex command is C9. We're going to do immediate mode. So we already have the immediate mode. Then we're just going to go ahead and add command C9. And that here. 0x, 0x, C9 colon. And then I'm just going to copy this. And we're going to do CMP. And we're going to do mode, what was it? Absolute? No, absolute? No, what was it? Immediate, duh. Okay, immediate. And usually this is where I say, it's a lot harder to code and talk than it looks. So let's go ahead and add the Python command. So we're going to do CMP, so def CMP, self and mode. And again, this is always going to be the same. So we're going to get the location based on the mode. Okay. And then in this location, did I do it wrong? I went the wrong way. Yeah. I don't have my mouse again, so yeah, it's hard to scroll. So then what we're going to do is we're going to compare the values. The value is going to go from self.memory location. Okay, so we've got the value based on the location, which is based on the mode. And then what we want to do with that is we want to compare it to the value in the accumulator. Okay, so let's go ahead and look at that. So compares flags as if the value here is equal or greater than. Okay, so if the value in the accumulator is equal or greater to the compared value, the carry will set. Okay, so fortunately we did that earlier. So I'm going to say if value is greater than or equal to self.a, whatever's in the accumulator, then we self dot set carry. What was that? SEC. And you gotta send the mode. Again, the mode doesn't matter in this case. It's just, it's going to be ignored. Actually, does it get ignored? SEC. Yeah, we got, ooh. Oh, that's a, are we okay on this? Let's take a look at the SEC mode. Yeah, it ignores mode, so it doesn't matter. Okay, so thank God. So we can go back to CMP and it sets the carry. That's the first condition. Okay, so set carry if greater than or equal to A. All right, and that's the accumulator. Let's go back. Sets the equal flag will be set based on equality. So if value equals self.a, and that is going to be C, SCD, SCI. Maybe it didn't do that one. All right, let's go back. Set equal. What's that one going to be? Set SCD, SCI. I think I messed up somewhere. Okay. Probably it's not set equal. Yeah, I know. You're probably watching like, what are you talking about? And I'm actually in that myself. What am I talking about? No, let's do a compare. The equal Z. Okay. All right, let's go back to here. Go back to here. I think I must have skipped that one. Okay. All right, let's go up here. It's probably because there is no SEZ. All right. That's interesting. Okay, branches, red flags. All right, I'm just going to go with this and see what happens. And since there is no set equal, I guess it's not something you can set. Okay, well, that makes sense. So we need to go back and add the equal flag. So let's go ahead and add that. Self.equal equals, we'll just set it to false to start with. And then we can't change that. Let's go ahead and put that down here so we can see that in the status. And as I said, I don't have this planned out ahead of time. So I don't know, hopefully you like that style. Equal. All right, so hopefully that's going to work. So now I can self.equal equals true. And then the final choice is, now I could have done self.carry equals true here as well. Let's go ahead and do that. Make it easy. Self.carry equals true. Not sure if it matters. And then over here, what's the last one? Compare. Okay, and the negative flag will be set based on equality or lack, or based on the sign of the accumulator. So sign is A is greater than or equal to $80. Explain that in a second. So if A is greater than or equal to 0x80, self dot negative equals true. I don't think I have negative set up here either, so that wasn't settable. Self dot negative equals false. Okay. And you can see the registers are actually pretty important. Actually, I posted about this on Reddit, and one person pointed that out. They said, "You didn't do anything about the registers." I said, "I know. I will get to that eventually." And the reason this says if A is greater than 0x80, this is because in 8-bit binary, actually, I have this. This is actually useful for the next part of this. You can see here, so 0 to 127 is treated as positive. So if you want to use this as a negative value, we use the last bit over here, which is 128, and that tells us that this is negative. So then 128 then becomes negative 128. 10001, 129 is negative 127, all the way up to 255, which is treated as negative 1. So yeah, there you have it. So if it's greater than or equal to 0x80, which is 128, then we treat it as a negative number. So yeah, that's how that works. Lucky us. Interesting. So let's go back and to our code. And I don't know if I need to do anything else. I need to do this. Probably gonna have to like make this a little bit easier to read. Negative. Let's go ahead and save that. Let's run this. Let's just make sure this still works. Okay, so I got rid of all the commands. It is running. I'm going to take that as a win. So let's go ahead and do a little bit of coding, and let's see if this works. So what we're going to do is we're going to do LDA. We're going to load it with 0, 1, and we're going to compare it to 0, 1. Okay. So let's go ahead and do that. That's going to be cpu.push. And I'm going to go ahead and copy that. And hopefully this is all we need really to test this. Okay, so let's go ahead and check our trackpad because we already have this. So 0xa9. So we're going to load that with 0x01. And then compare was C9. Okay, scratch pad. So A9, C9, 0x C9. And we're going to compare that with 0x01. Then we're going to do cpu.push. We're going to do our debug command, which is 0x42. All right, so let's go ahead and run it and see what happens. Okay, so you can see that carry is set to true because they are equal. Sorry, equal is set to true because they are equal. Carry is set to true because they are greater than or equal to. And negative is set to true, which it shouldn't be. So let's go ahead and figure out why that's doing that. I think that meets the requirements. Let's take a look at the code again. Just two. Self.a is greater than 0x80. Self-negative equals true. But self.a is not greater than or equal to 0x80. Well, that's weird. Alrighty, let's go back. Load 0x01. The value of A. Let's go up here. And this is the fun part. A is 1. Is it greater than 0x80? This doesn't make any sense. Alrighty, let me take a look at that one more time. The 0x80 is what's throwing it off. Let's change that to 128. And yeah. Let's try it again. Run that. So negative is true. Why is that happening? I didn't make it true, did I? I guess that would be something I would do. Self negative is false. All right, let's go ahead and just check here real quick. Let's go ahead and add a little more debugging. So, let's debug that again. Okay. Okay, false, false, false. Now we're going to execute compare. And negative is true. Why is that happening? Probably everybody watching has already figured it out, but equals 128. Print cmp f self dot a equals self dot a. 128. Why is that doing that? That's so weird. Okay, I'm gonna not get upset about this. Sure, that's really confusing. Self dot a. It didn't print that. Why is that? That's very strange. Okay. Save that. Or did it? I just missed it. Okay, then we hit enter. Self A equals 1. Yeah, okay. Why is negative? Yeah, I did. Not even looking at what I did. I didn't change this, did I? Yeah. All right. Anyway. It's hard to do this and talk. All right, let's go ahead and run it. Okay, it's blocked up. I'm gonna go ahead and restart. Genie. All right, here we go again. Okay, negative. There we go. So carry is true, equal is true. So let's go ahead and test a couple other values that should be correct. So in this case, it was equal and greater than. So let's make it greater than this time. So we should see the carry flag set. That was dumb. Carry flag, but equal should not be set because they are not equal. I didn't save it. It's Control Z. Okay, it's one of those things you gotta make sure you save it before you test it. All right, and true and equal, that is not good. All right, that's not working. All right. I'm kind of rushing because I have an appointment and yeah. All right. Anyway, let's get rid of this debug. We don't need it anymore. So I changed it here, but didn't change it here. Duh. All right, one more time. Okay, so now carry is true because this is greater than or equal to this, but all the rest are false. Fantastic. Control Z, and then let's test a case where it's less than. So let's make this 2, make this 1. So I did save it. I gotta change this here. That was brilliant. And let's go ahead and run it. So carry is true. Negative is false. That's not what we wanted. So why are carry and equal true? Because I didn't change this. I'm gonna just do the same wrong thing a million times in a row. All right. Okay, false, 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 false. So it's not equal, it's not greater than, and it's not negative. So let's go ahead and load this up with a negative value. So let's just do 90 since it's bigger than 80. And Control Z. And negative is false. Because I didn't change. I really gotta like get some kind of assembler work. I do have a basic one, but I don't like playing off it. Anyway, negative true. All right, so I'm gonna call this a win. Okay, so now there's a lot more that we need to do with the interrupts and things, and not the interrupts, but the flags. But I think this is doing what we want it to do. Okay, so yay. Now that we have this working, now I can go back and I can just go ahead and add all the other, all the other memory modes for this, at least the ones that we've done. But what I want to do is I want to get to branching because this is already going to be a long video. And yeah, maybe I should have separated these two, but you can't do one without the other. So let's go ahead and do that. Actually, you know what? I'm going to just go ahead and do the other branching modes. Take a break. Next video, we'll come back and do branching. How's that? Yeah, I'll make these a little bit more digestible chunks. So let's go ahead and go back to compare accumulator. And I'm just going to go ahead and copy these various values or these various information, make it easy on myself. And I'm going to go ahead and copy that. And I'm going to go ahead and just delete what I don't need. All right, there we go. So this will make it easy. So make an executive decision here. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 6. Need 6 more of these. 1, 2, 3, 4, 5, 6. Yeah, I'm not sure I've done all these yet. So let's go see. 0 page. Where are the modes? 0 page X, absolute X. Okay, we haven't done indirect X and indirect Y yet. Okay. So we're going to be able to do these ones. All right, that's fine. That's a pretty good day. So C5. I'm not having a coding day here. C5, and that's going to be 0 page. And we have D5, which is 0 page X, 0 page X. Then we have, right at immediate, absolute. So that is CD, absolute. And we have absolute X and absolute Y, which is DD, D9. So X, Y, and I think that's it that we can do. Yeah, there we go. And those are the ones I think we have code for. Now again, I should probably test this, but I don't have the time or energy right now. And clearly I'm not really on top of things here. Again, it locked up. I'm not sure why it does that sometimes. There's probably a good reason for it. Okay, and that's still giving me, which is what we had at the end there last time. So I'm going to call that a win. All right, I think that's a good place to stop. So yeah, so anyway, sorry I thought I'd get more done in this video, but I just wanted to stop here and I'll do the other part next time because it is pretty complicated. So basically, we've implemented the compare command. So CMP, oops, not sure why it's doing that. Sorry about that. Implemented the CMP command, and what that does is it compares the value in the accumulator, and based on the value, is it greater than a certain value, it sets certain flags in the CPU. Now later, those flags we're going to use for branching, but we'll do that in the next video. Again, I do apologize for not completing everything on the list here. Got a little ambitious, a little overly ambitious there. So let's call that a win. Thanks for watching. Subscribe. Hope you're enjoying the series. Take care. Keep on coding.